and welcome to our second show of Teaching Mathematics. Today we are joined by Dylan behind the computer, and we have Robin again with us. Hello, Robin.
Hi, Helen. Great to be back here again.
Oh, it's good to have you. Now, before we begin on all of our discussions, remember that you can tweet us at the hashtag VTMaths. So that's VT, the letters, and maths. Okay, Robin, I know last week you did tell us a bit about yourself, but why don't you refresh our memories?
Well, I'm currently teaching at WITS. I'm teaching teachers to be maths teachers. And before that, I was a maths teacher myself at a high school in Randburg.
Oh, fantastic, thank you. Okay, well, we're starting off by looking at what's in the previous grades, and we'll start by looking at what's going on with grade 12.
Yes, I believe we're doing a bit of a refresh.
Okay, Robin, tell us about grade 12.
Well, at the end of term 1, which is now feels like in the very distant past, they would have just finished trig,
Yes.
which is compound and double angles. And at the moment, they should be doing 2D and 3D trig.
Now, we did talk a little bit about this last week, and we were talking about using real examples and things like that. I understand that you've supplied us with a link today that we can look at of some resources.
Yes, I have. The link is from Siavula, and it's their chapter on trig, and the page that I've linked over there is all the applications of trig functions. So it's going to be the sine rule, the cos rule, and the area rule. And then further down on the page, we get to 3D problems in trig.
I see that they start with the 2D problems, and I see some
Yes, they do.
circles going up on the screen.
With cyclic quads.
Yes. And then still problems in 2 dimensions.
Yes, and
then 3 dimensions over there.
yeah,
Heights of buildings and things like that.
flagpoles, trees, etc., etc.
Now,
Yeah.
I know Siavula has textbooks for grade 10 and 11. They're all called Everything Maths.
Correct, yeah.
Yes.
And they're freely available online. And all you have to do is go to www.everythingmaths.co.za, and they're freely available textbooks. And then if you're willing to pay a little bit extra, you can do their practice.
Oh,
It's called intelligent practice.
well, that does sound useful for someone who, grade 12, who maybe hasn't
Who's
quite,
struggling, yes.
got
But
it
there are
yet.
also end of chapter exercises in all of the textbooks which you can practice from.
What I like about all of the textbooks being on the same platform is that a grade 12 learner could go back to grade 11 and even grade 10
Correct.
if they needed to at no, well, other than the data cost, no other extra cost.
Well, Siavula has also done an amazing thing in that they've published all their textbooks on Mixit. So if you're
Oh.
worried about data costs, then you can access these on Mixit. You go into the section called Mixit Reach, and you can find it there.
Now that's really fantastic for a student. Well, I'm a teacher and I'm wasting time now reteaching grade 10 and 11 work. I can just tell my student to go onto Mixit and get the work themselves.
Yes, they can, and it's very easily accessible.
Okay, what are we moving on to after 2D and 3D trig?
Well, there's it'll be a very short section called polynomial functions, which
Okay.
is meant to take 1 week to teach.
Okay, and that's like the remainder theorem and things like that.
Exactly, yes.
Yeah.
Yeah.
Okay, well, let's take a look at grade 10. Okay, last week we did talk quite a lot about what's going on in grade 10, and it was
Yes, we did.
algebraic functions. So I don't think we need to talk about what they did before it, because we did talk about it quite a bit then. Why don't you tell us what they should be doing at this point in algebraic functions?
Well, they should be in algebraic functions, and by this point, I guess that grade 10s should be looking at the different shapes of the functions. So quadratic functions, what shape it is, exponential and hyperbolic functions, and then obviously in the weeks to come, they'll be moving on to more of the application of those functions.
Okay. And what are they moving on to after algebraic functions?
They're sticking with functions, but this time it'll be trig functions, so it'll be
that's always
sine, cosine,
a lot of fun.
tan graphs.
Slight sarcasm there. They don't always get it the first time, do they? The
No,
trig functions.
it's I think the difference between algebraic functions and trig functions is that trig functions continue forever, and that's
it's a difficult concept
very
for them to
difficult
get in the beginning. Now, if you are watching and you are concerned about teaching grade 10 trig functions, we are doing a show on it in 2 weeks' time. So join us again in 2 weeks where we'll be discussing it more. What are they moving? Well, we've discussed they're moving on to trig functions.
Yes.
Okay, well then what can you tell us about grade 10 overall?
Well, on the slide over there, there's another link.
Yes.
And that link is to the end of chapter exercises, also in Siavula. And it just gives learners a chance to practice everything that they've already learnt in the section.
There seemed to be quite a long list of problems over there.
Yes, there is. And if I'm correct, this page actually also has trig functions, so learners will be able to practice their trig functions once they finish that section as well.
Are the answers supplied?
I think there are a few answers supplied, but not everything. No.
Okay,
I'll have
so
to check up on that.
Ideally a student would need their teacher to maybe give them some of the answers.
Yes.
Okay, well, let's move on to the focus of today, which is grade 11 functions. Okay, where have we come from to get to this?
Well, grade 11s should have just finished at the end of term 1, analytical geometry.
Okay.
And before that, they would have done the basics like surds, exponents, and other algebra.
And this is all relevant for functions?
Yes, it is. It provides a good basis
to
functions.
How do exponents and surds help with functions?
Well, functions, with exponential functions and as well as quadratic functions, you need to have a good understanding of what exponents do, how they work. And with surds, well, sometimes you get a function and there's a surd in there and you need to know how to get rid of it.
Yes. And surds can be confused. I think even the word surd gets some students confused.
Mm-hmm.
Do you have any tips for people who they haven't mastered those concepts? How would a teacher know that their student hadn't mastered the concept of exponents or surds or anything like that?
Well, for your first question, I think that my tip is I always like to keep surds in surd form, because you find that so many learners are very scared of surds, so they convert it straight into a decimal.
Yes.
And then when they work with it, they lop off the end and just forget about it. So when it comes to converting it back into a surd, they don't really know how to do it. So my advice is just, if you have a surd and you're working with a surd, keep it in a surd. You can use your calculator to find out the approximate value of it, but when you're working with it, rather keep it as a surd.
Okay.
Your second question is some tips.
How would you
use it?
Diagnose?
How would you diagnose a misconception? Well, I think it would be in looking at learners' work.
Yes.
To see where they make mistakes, and also in their talk. If they're not confident in how to talk about surds, then you might be able to see that there's a bit of a problem. And I just thought of one other use for surds.
Yes.
When you're working with quadratic functions, then sometimes you do get your roots in surd format.
Yes,
so that
you do. And of course, we didn't have to do nature of roots with the previous curriculum, and now in CAPS we do need to do the nature of roots. Mm-hmm. It's not in huge depth, but it's still there. Yes. You need to know all of those.
In the first term you would have done the nature of roots, and are there any real roots of a expression, and then that comes into play when you're doing quadratic functions to be able to see are there any intercepts in the x-axis.
Yeah. Okay. Now, what kind of concepts? Last week we spoke quite a bit about grade 10 content. Maybe we can pull up the slide of the formulae. There they are. We had the linear function, the quadratic function, hyperbolic function, and the exponential function. And those are all the grade 10 formulae that they would have used.
Correct. And as you can see, it's quite basic because the two characteristics that you look at are A and Q. A usually tells us either the direction that the graph is going in, whether A is positive or negative, and kind of how fat or thin or how far the stretch of the graph.
Yes, like the shape of it.
The shape of it, yes. And then Q will tell us the vertical shift of the graph.
We did speak about that quite a bit. Remind us again why it's better to talk about the shift rather than other things.
Well, when we were in grade 9, we did y equals mx plus c, as it was called then, and now we call it y equals ax plus q. And teachers were very eager to say q is the y-intercept, and that's that. But when we go on to hyperbolic and exponential functions, we need to be very careful because q isn't always the y-intercept. It usually shows us the asymptote on the y that goes through the y-axis.
And it doesn't always show the asymptote, or does it show the asymptote?
It does show the asymptote.
Does show the asymptote. Okay.
So I prefer to call it vertical shift because it shows how much up and down the graph is shifting instead of the intercept.
And that description applies to all of the functions then. The amount that q is the amount that the shift has happened in the shift. Okay, well, now that we've done a brief revision, let's go into grade 11 content. Tell us what we need to know for this section.
Well, first I'm going to tell you about how much it counts out of for the exams.
Yes.
So algebraic functions is in paper 1 of the exam, and it should count for about 45 marks out of 150.
That's quite a lot. That's almost a third of it.
Exactly. It's in the final exam.
Yes.
So it's a huge amount. And in grade 11, we focus generally on 3 functions: quadratic, exponential, and hyperbolic functions. And our linear functions have they're still there in terms of the application sides, but they also feature quite a bit in analytical geometry.
Yes.
So analytical geometry counts for 30 marks out of 150, and that's in paper 2.
Okay.
And if you're busy starting to set your mid-year exams, functions should count for 25 marks out of 100 in paper 1.
That's quite a section. So while they're teaching, or while it's being taught now, you've got to remember that the whole time. It's always a nice teaching technique as well to remind them how many marks are
in
for that section.
And how important this section is.
Yes, I find that learners work harder if they know what they're working towards. Yeah. Okay, now the content that's in it.
So
what's different?
So what's different is that if we have a look at the CAP statement, we can see here that we're focusing on 3 functions, and that is quadratic, exponential, and hyperbolic. And the difference is that we now have a new characteristic added to our functions, and that is p.
Okay.
So in all 3 cases, we can see we have x plus p, and x plus p. Where the x was, there's now a plus p, and that is the characteristic of horizontal shift.
Okay. So
that's
q is vertical, p is horizontal.
Correct. And that's something new that we see in grade 11. In grade 10, learners were only expected to look at vertical shift, and now they're expected to look at horizontal shift as well.
Okay. This can confuse quite a few. Hold on a second. They all say plus p, but when I was teaching it, they were minus p. What's happened?
So I'm not too sure what has happened, and this is important because there's still some textbooks which say, for example, let's put up the quadratic function, y equals a, x plus p squared plus q. And in some textbooks you'll find that it's y equals a, x minus p squared plus q. Now, I don't really find that the sign is much of a problem as long as you understand how p works.
Yes.
And p works as a horizontal shift. And it works in the opposite direction that you think it does, because q is pretty straightforward. If we have a positive q value, our graph shifts up, and if we have a negative q value, our graph shifts down. But with p, it's the opposite to what you think it is. So I think that back in the day, p was put as a negative to remind you that it was opposite.
Okay.
Now we have plus p, and I don't think it necessarily matters as long as you understand what P does.
You know what it does matter for is for teachers who are teaching routine procedure, and they're teaching that the turning point is PQ. Now suddenly, with the change in formula, it's being x plus p, the turning point is no longer PQ, it's actually negative PQ. But if you are teaching from an understanding point of view,
it shouldn't matter.
It shouldn't.
You're very right, and I think that's a trap that many students fall into. Is that they're not interested in understanding why it works. They just want a recipe. They want to say, if this is my formula, this is my turning point, and that's all I need to learn. But learners should be careful of falling into that trap and rather understand what P does to my graph, and then they'll see that to find our turning point, or shall I just say my axis of symmetry on the x-axis.
That's a good idea, yes. While you're writing axis of symmetry, remember that your axis of symmetry is the line at which your function is reflected on both sides. Not reflected, it's a mirror image on both sides. Yes.
So my axis of symmetry would be that line over there. I've drawn a little bit skew, but it should be where the line that goes through the turning point, so that the left-hand side mirrors the right-hand side. So to find our axis of symmetry, what we really want to do is we want to say, well, I want to find x plus p and make it equal to 0. So therefore, over here, x is equal to negative p. And this is for, negative p.
There we go.
And then for this graph over here, depending on whether you use your equation with your positive p or your negative p, for this one we would say, well, x minus p equals 0, therefore x equals p. Sometimes the brains and the fingers don't work at the same time. So I'm glad you pointed out that I forgot the negative.
Well, it's a common mistake in exams, isn't it?
It
Children will be at that very last step, and they'll just leave out the negative, and
we call it careless errors.
Yes.
Careless errors, unfortunately.
Yes. Kills me.
So we just have to make sure that that we see why this works and how it works, and then we'll be instead of using a recipe, we'll be able to understand.
Yes. Now, my assumption is that with the matric exams being the first lot of CAPS exams that are happening at the end of the year, on the formula sheet we'll see x plus p.
But many learners will still be
using old textbooks.
Using the old textbooks.
Yes. I didn't leave the classroom that long ago, but I know my old textbook, which may be 3 years old, had the x minus p there. Yeah. So it's a good idea to teach. It's more than a good idea. It's a fantastic idea to teach understanding and how to cope with both.
It is.
Okay. Now, we've talked about this ax plus p squared plus q, but we both know that this isn't the only formula that quadratic functions can be presented in. Why don't you touch on that a bit for us?
Sure.
And now this one is y equals ax squared plus bx plus c.
Yes, we do have another formula, and that's usually y equals ax squared plus bx. Now I'm writing in the wrong place. Plus c, and this is the quadratic formula that I think most of us are very used to, because we can the thing that you can do easily here is factorize. Which finds us our roots very easily. So this is one advantage of using this formula over here, if we factorize to find the roots of our equation.
Now, we spoke about this last week, about how learners don't want to cross the divides. They don't want to apply factorization to functions and things like that. I can see one of the issues being they won't want to apply completing the square to this problem over here.
Exactly. So then the second thing that we can do is complete the square to get it into the form of y equals a x plus p all squared plus q. So we can complete the square over here to get it into this form, obviously, which then helps us find the turning point.
Yes.
And I think that often this form of equation is often called the turning point form.
Yes. Yeah. I know when I was in high school, we worked a lot more with the y equals ax squared plus bx plus c, and then we had the turning point formula, which was...
Yes, another way to find the turning point is to, or at least the x value
Yes.
of the turning point is minus b over 2a. Am I correct?
That you are. And I think that's a really good point that you put the
Yes.
x value there, because often you find that learners stop once they've done their calculation. They think that, okay, I'm done now.
Correct, yes. I've often also found that if you say find the turning point, many learners have learned this little ditty
Yes.
so off by heart that all they do is substitute in minus b over 2a and leave it as that, which is actually just the x value or
Yes.
the x, or shall I say the axis of symmetry as well on the x, the vertical axis of symmetry.
Yes. Now, you've mentioned the axis of symmetry twice. Is that a common question to be asked in tests and exams?
I don't necessarily know if it's that common, but it's a very important concept, because one of the features of a quadratic graph is that there's a turning point, and this turning point is on the axis of symmetry. So if we're finding, and it goes through the x-axis. So if we find the axis of symmetry, or the x value of the turning point, it's this point over here.
Okay.
Then to find the actual turning point, we need to substitute our x value back into our equation
Okay.
to find this point over here.
Okay. So in terms of quadratic functions, what we're introducing is the concept of p, which is the horizontal shift.
The horizontal shift,
Okay.
correct.
And then we're possibly talking about the ax squared plus bx plus c. And I say possibly because it's not actually listed in the CAPS document.
No, if we perhaps go back to the CAPS document page, which is one slide earlier, then we can see over there that it basically just gives us the three equations, and it doesn't really explain very much else other the CAPS document just says you have to be able to sketch the functions, and there are a few application questions, but it doesn't go into detail as to what types of questions will be asked. It doesn't give very many examples. So I find the CAPS document in this case very thin.
Offhand, do you know how many weeks we're meant to spend on this section?
Yes, it's meant to be 4 weeks.
4
in
weeks.
this section.
Okay, so there is actually more than enough time to do the quadratic function
There is, yeah.
in sufficient detail. Those 4 weeks, do they include the trigonometric functions as well?
Yes, I think they do.
Okay.
Yeah.
And
Yeah, what you'll find here is that if you have a good textbook,
yes.
or if you go to perhaps exemplars on the Department of Education website, you get a better idea of what type of questions will be asked in the exam.
Yes. And of course, it would have to be a department-approved textbook
Yes,
in order for you to be
Mhm.
confident in what's put there.
Yes.
Okay, now, is there anything else we need to know about the quadratic function, or can we move on to the hyperbolic
We can
or
move on.
hyperbola? Okay,
Mhm.
tell us about the hyperbola.
So the hyperbola will have a general formula of y equals, we can move on to the next slide again, and just put it up quickly. Y equals a over x plus p plus q. And so this is our general formula for our hyperbolic function. And p and q in this case are very nice because these will give us the asymptotes. But once again, we have to remember that q works in the way that we think it should work, in that if it's positive, our whole graph shifts up. And if it's negative, our graph shifts down. So, for example, that's if q is positive. However, p, once again, works in the opposite direction to what we think. If p is positive, it's actually going to be moving left.
Okay.
And if p is negative, it's going to be moving right. So what we can do over here is if we say x plus p equals 0, then we know that x equals negative p. So if P is positive, our P has shifted to the left.
Okay.
And
I know
then
with the quadratic function, I always get muddled up with the plus and the minus with the P. But what I like about this P is that it is the denominator of a function, so it is actually really easy to work out.
And we know that that there's going to be an asymptote at the point where P is the additive inverse of x, which makes 0. And obviously, fractions don't exist when the denominator is 0. It's undefined, and that's why we have our asymptote there.
You've used two beautiful words there. Additive inverse. Yes. Why don't you explain that quickly?
So an additive inverse is a number that, when added to your other number, makes 0. So for example, if we have 2, the additive inverse will be minus 2. Add them together, you get 0. If we have a number of minus 3, the additive inverse will be 3. Add them together, you get 0.
That's a really nice party trick to teach to your students. Yeah.
But the nice thing about knowing what your additive inverse is that when anything on the bottom of a fraction is 0, it's going to be undefined. And when something is undefined, there's no way that you can draw it, and that's where you get your asymptote.
Okay, and of course, just to revise for revision's sake, the asymptote, the function will never, ever, ever touch.
It won't. No,
yes.
It might become infinitesimally close,
yes,
which means very, very, very close, but it will never, ever touch the asymptote.
Okay. I must tell you a funny story at this point. When I was teaching this to my grade 10s, asymptotes for the first time, at that point, Heath Ledger was still alive. And he was pretty good looking. And so I would teach the asymptote, say, as much as I love Heath Ledger, I can email him, I can call him, I can write letters, but I'm never, ever, ever, ever going to get to touch him.
I thought you were going to say he's got a very nice asymptote.
Well, yes. So, now last week we spoke about A as well.
Yes.
Does A still have the same function over here?
It has the same effect, yes. So if A is a bigger number, our graph still stays very close to the asymptote, but the shape of the graph changes slightly. And the bigger A is, kind of the more it pushes our graph away from. It kind of makes it wider. And then the other effect that A has is it depends on whether A is positive or negative. If A is negative, it actually switches quadrants. And I think have I done this the wrong way around from the start?
I'm looking at it upside down.
You're looking at it upside down.
I'm sorry.
Well, so if A is positive,
yes,
it's in quadrants 1 and 4.
Yes.
And if it's negative, it's in quadrants 2 and
1
positive 1 and 3, negative 2
and 4.
There we go.
Okay.
Got that sorted out.
Yes, we did. And now there are two things that have happened here, and I hope you don't mind me pointing them out. Firstly, you needed reminding about the plus P, and secondly, about where the quadrants were. But the skills you demonstrated there, where you found out what the answer was before moving on to the next thing, it's a really important skill to have as a teacher. So many times, you're in a maths class and someone taught something wrong, one lesson 5 years ago, and this child is still carrying that wrong information.
Yes.
Yeah.
In fact, I find one of the most important skills in maths is accepting that you can make a mistake and then self-correcting. Because imagine you did everything right from the start, then you wouldn't know what was necessarily wrong and right. Whereas if you make a mistake, you're able to say, I've made a mistake, I've done something wrong. Now I know what's wrong, and I can correct that.
This touches on something else. This is one of the reasons I love teaching maths, and that it teaches you how to deal with failure and how to get up and try again and try again and try again until you get it right. It's a fantastic skill, and if maths teachers focus on that, so many more people will be doing well.
Yeah. In fact, I've recently read some work by a lady called Caroline Dweck, and and I think the teachers should really go and research this if they have the time and the energy.
Do you mind writing her name?
I will write.
Quickly. Thank you.
And she speaks about something called a growth mindset and a fixed mindset, or I should say it the other way around. A fixed mindset is actually the one that you don't want to have, because you're very fixed in your ways.
Yes.
You're not able to accept that you might have made a mistake. Whereas a growth mindset is you're always willing to challenge yourself, you're willing to grow, but by growing, you understand that you'll be making mistakes and learning from that on the way.
Okay. And her name is Carolyn?
She's actually a psychologist, but
Okay.
she's done a lot of work with maths educators to research her theory of fixed growth sets and fixed mindsets and growth mindsets.
Okay.
There we go.
Okay, and for our viewers out there, I have started a blog, and I'll put this onto the blog. The blog's address is teachingfet.wordpress.com, and I'll find some work by this woman.
And put it up there.
I'll put it up there.
It
Yes.
certainly is a very, very interesting read, and it's informed my way of teaching very much, in that I encourage learners to make mistakes, but I also encourage them to self-correct their
Yes.
mistakes and learn where they've made a mistake, and not take it to heart and
Yes.
be devastated that they've made a mistake, but rather see it as an opportunity for growth.
Yes. Fantastic skill in today's hectic work life. Yes. Okay, now we've done the two functions. Let's move on to the third one, the exponential.
So our exponential function is y is equal to a times b, and here we get our horizontal
Yes.
shift plus q. Now the important thing to remember is that b over here cannot be equal to 1, and b should also be greater than 0.
Okay. This comes into play quite a bit with the inverse functions next year in grade 12.
It does indeed, yes.
Yeah.
Logarithmic functions.
Yeah.
Well, first of all, the reason that b can't equal 1 is that if this is 1, 1 to the power of anything is 1. So you'll just end up having a graph that goes on 1. I mean, not taking into account our shift.
Yeah.
But that isn't an exponential function, so that kind of defeats the object.
Okay. Okay. Well, let's begin. Horizontal shift, vertical shift, shape of the graph. Is there anything else that we need to know about the exponential function?
Well, the exponential function, I always like to draw this diagram, and some people say it looks like a star, it looks like whatever, but it's basically something like that. And then we have our reflection. Have you seen something like this before?
Yes.
So if we look at our graph, this is probably the one that most people recognize.
Yes.
And this is where a is greater than 0. And this one over here, everything is reflected. Our positives on our x-axis become negatives. And this is where a is smaller than 0. Am I right, or did I get it all wrong?
That says greater than 0.
A is smaller than 0. There we go.
Okay.
And whereas... No, I am wrong. When it's reflected this way,
Yes.
it's where a is smaller than 0.
Okay.
And where we go over the axis this way, it's where a is a fraction. So it's between 0 and 1.
Okay.
Are you checking up on me?
Yes, I am.
Okay, that's very good, because that's the way I remember it. And then what happens with Q is whether we move up and whether we move down. And obviously, our asymptote is going to be over here.
Okay.
and
And
whether
the
we move up or down, the asymptote moves up and down according to Q. And our p-value will tell us whether our whole graph shifts either left or right. And once again, we need to be careful of this p. We need to make sure that we say x plus p is equal to 0, therefore x equals negative p. So it's moving in a direction opposite to what we...
Okay, and that would be to determine the amount of shift that's happened.
Correct. It's a horizontal shift. So how many units we move left or right. If p is positive, we move left. If p is negative, we move right.
Okay. Now, in my mind, it would be easier for me, with the way I work things out or calculate things, to rather work out the x or the y-intercept and the x-intercept and then plot according to that.
I see. I now know where I made my mistake.
Yes.
This is where b
Yeah, I thought it might
is in
be
between 0 and 1. Well, you should have said.
Well,
and this is a, and where a
yeah.
is positive and negative reflected over the x-axis, where b can only be greater than 0.
Yes.
But not equal to 1. So where b is a fraction, we have it over here and here.
Okay.
Yes. Where b is a number bigger than 1, then it looks like our normal shape.
Okay. You know, we keep coming back to this, but the Ciavula textbook has a really good diagram that shows all of these.
Yes.
Yes.
Yeah.
Is it necessary to know all of these off by heart in order to cope with doing an exponential function?
It's not necessary,
Yes.
but it will take learners longer in exams because they'll have to figure it out from the start by either plotting a function from the start. So I like to know what
kind of shape
what
it
characteristics each part of the function tells us, so that we know what shape the graph is.
has. Okay. Okay, so the shape in this case relies on A and B.
Correct, yes.
Okay.
And then where it is relies on P and Q. If it's shifted up or down, if it's shifted left or right.
Okay. Okay, so any tricks to teaching this other than here you go, here's your picture and you must learn it now?
Well, what I like to do when I teach functions, and especially this, is that I vary one characteristic at a time.
Yeah.
So you might do something like y equals, and then we can, let's just set, for example,
You
b.
spoke about this last week, variation.
Yes.
Where
variation.
you change one thing at a time.
So if you change A, make it bigger, make it smaller, make it positive, make it negative, then learners start to see that's what A does. B, keep A set, and B.
Okay.
Make it a fraction, make
Yes.
it a big number, see what that does. And then set these two, vary P, see how it moves. And by varying one characteristic at a time, or one of these four characteristics at a time, then you'll be able to see what effect each has on the function.
Yes.
And start to understand it like that.
Okay. Now, I can hear a whole lot of maths teachers in South Africa going, but where do we have the time? How can we do this? What are your suggestions to those maths teachers?
That's very true, and it's difficult to find the time, but I think first of all, I think it's a very worthwhile exercise. And plotting a graph point by point is something that learners really should be able to do by now.
Yes.
So they can easily do it as homework without the teacher standing over them saying,
would you recommend using the table method on their calculators? Or
that is possible.
Okay.
That is possible. I know that many don't have calculators, so it's also fine on pen and paper. If a teacher has access to a computer, perhaps they could pull up a graphing software such as Autograph or GeoGebra, GeoGebra is free off the internet.
Yes.
And using the slider function to vary each variable, that would show it. But I know that not many teachers have access to that either. So there are some, you can plot it just with a pen and paper.
I
So I
suppose
think
you
it
could
is
do
important.
group work where each child plots a different function with a different variation.
That would be very clever, because if there's 4 variables, then groups of 4 would work. I'll do A, you do B, you do P, you do Q, and work together like that, and report back to the class.
Or I'm brainstorming here. Let's say we have one group that's just focusing on variations of A, the next group on B, and then P, Q, and they present it
to the class.
Yes.
Yeah, that's
of course, then you
idea.
have to... I'm full of them. But then you would have to make the graphs on quite large paper.
Yes, or they could draw their findings up on the whiteboard or the chalkboard.
Yes.
At the end of a lesson.
Yes. Now I'm thinking 30 in a class, if you're lucky. 30 functions, it's going to be chaos. 30 pieces of chalk.
Well, that's
just
what
thinking practically here.
That's what teachers are best at doing, is thinking on their feet and finding a way.
I suppose, if I were doing it, I would
Yeah.
quickly draw up a set of axes on a couple of sheets of paper.
A very large paper.
Yeah.
That's a
And
very
then
good
do
idea.
it that way.
Yeah. I think it's essential to just get learners to understand that if you have a positive function, it's going to be on the positive side of the axis. If you have a negative function, it's now going to be all your values are going to be negative, and that's what you've understood. And in terms of B being a fraction, because B is a fraction, let's say for example we have y equals 1 over 2 to the power of x.
Yes.
1 over 2 can actually be written as y equals 2 to the power of
Negative
x. And where your x values become negative over here, that's why your answers are now positive. Where your x values are positive, your answers are very small. They're under the value of 1. They become fractions themselves.
Okay.
So I think that's the concept that you want learners to have, the understanding, is why it works.
Okay.
Does that help you, Helen, or not?
Yeah, you see, I'm the kind of thinker who has to see the calculation. So in my head, I'm going, x is equals to 1, so that's 2 to the power of negative 1, which is a half, which would be over there. If x was negative 1, then it would be 2 to the power of 1.
Should we do one that has that has a fraction?
Let's do it just quickly.
So let's...
and why don't we throw in a value for a as well?
Let's do one without an a, and then let's do one with a negative a and see what difference that makes. So if I plot, for example, y equals a half x.
Okay.
Now instinctively I know that it's going to look something like this.
Okay.
But let's plot it out to make sure we know what it looks like.
What typically do you get marks for when plotting a function?
You typically get marks for your y-intercept, your x-intercept if there is one, and any asymptotes involved.
Okay.
And also if the shape has to be correct. Obviously, we're not looking at an exact shape,
Yes.
and it doesn't matter if it's slightly out. But we need to know that you're drawing an exponential function and not a parabola, for example.
Yes. I know the most interesting shaped graphs are children who are trying to plot the tan graph point by point.
Yes, that gets out of hand very quickly.
Yeah. Okay, so x to the power of half can be x to the power, not x to the power of half to the power of x.
Can also, you can also write it as 2 to the power of negative x.
Okay.
So let's have a look at it like this, where x is 0, 2 to the power of 0 is 1.
Yes.
So we know that where x is 0, y is 1. So it's going to go through this point.
So we've got 1 mark so far in
we do.
Test.
And we also know that because there's no vertical shift, basically if there's no q value, we know that it's plus 0. We're going to have an asymptote on y equals 0.
And that
which
is
the
grade
x-axis.
10 knowledge, so they do know
that's
that.
grade 10 knowledge. here. So where x is 1,
Yes.
I know that half to the power of 1 is half.
Yes.
And where x is 2, half to the power of 2, it's going to be 2 to the power of negative 2, and it's going to be a quarter.
Yes, it is.
And that's about as far as I'm going to go on that side, because I want to look at my negative side.
okay.
So I know that where x is negative 1, 2 to the power of minus x, and if I substitute in minus 1, it's going to be 2 to the power of 1, which is 2, because a negative times a negative is a positive.
Yes.
Are you following me?
Yes, I am.
Mm-hmm. And let's find a value for minus 2. 2 to the power of negative 2 is going to be 4. So as we can see here, everything is reversed.
Okay.
We would expect our usual graph to look something like that, but because
B
it's
is
now
a fraction.
it's now going to be the other way around. So we
Okay.
say where x is 1, y is a half. Where x is 2, y is a quarter.
Yeah.
So we can see that it's going to be going very close down to here, and it's also almost going to lie on the x-axis. Whereas on this side, where x is negative 1, y is already 2, which is somewhere up there, and where x is negative 2, y is 4, and as you can see,
It increases
it kicks
exponentially.
up very quickly, and
Yes.
that's why it's called an exponential graph.
Okay. Now, we are coming to the end of time, and I want to discuss a bit more about the application questions. I know you've got some links, so I'm going to skip past the effect of A on these
No problem.
and skip straight to your links, which you've got a link for quadratic functions, for a textbook chapter, and for the end of chapter exercises. Tell us about this first link.
The first link is it's
It looks
a PDF,
like a PDF,
and
yes.
it's a wonderful long lesson dedicated to quadratic functions, and I found it to be very useful because it shows all the different forms of the equation that you can use with quadratic functions. It shows how to get roots. It shows how to find a turning
Yes,
point.
we haven't
the
spent much
axes.
time on roots at all. Yeah.
It shows how to complete the square to get from y equals x squared plus bx plus c to our normal standard form that we find in grade 11. So it's very nice in that it shows the graphs, the shapes, the effects of A, making it a smiley face or a sad face. So
It looks comprehensive.
it's a very comprehensive lesson on quadratic functions, and I usually found that in the exam, quadratic functions was the section that was that carried the most marks.
Yes.
Even though exponential and hyperbolic functions are tested, quadratic functions are usually tested the most because I find them the most interesting. It has the most applications to
I
real
would
life.
assume that those questions then would be the level 3 and level 4 questions, and the other two would be level 2 and level 3 questions.
Not necessarily. I think it depends on how the questions are asked. I think if you ask just to sketch a function, whatever function it is, then it's a level 1 and 2 question, or to find the roots. Whereas your level 3 and 4 questions come in with applications such as finding lengths between two lines of a line segment.
Oh,
and
learners love that, don't they?
intersections of two graphs.
Yes.
And you could actually get an intersection of a quadratic with an exponential and calculating for that.
And of course, to find the intersections, you would have to do simultaneous equations.
Exactly, yes.
Yes,
Yeah.
and it's that getting that thought across that where the two graphs meet, they have equal x and y values.
Correct.
Yes.
And then finding the distances between two graphs, where you take the top graph on the top and you find the graph on the bottom, and you actually subtract the one from the other to find the distance in between two.
I saw a particularly nasty, and I'm stealing one of your pens.
Go for it.
I'm going to, it doesn't actually matter whether it's upside down or not. Particularly nasty question in a grade 11 exam where they had to find the maximum distance between the two parabolas.
Yes, I've seen that question before. What you would expect a learner to do is, first of all, I'm just going to name this f of x and g of x.
Okay.
To help us. As you can see here, f of x is on the top here and g of x is on the bottom. So what you would first do is say f of x minus g of x. And because they're both quadratic functions, your answer would be a quadratic. And that's where most learners get stuck.
Yes.
Because they get an answer of this quadratic function and they don't know how then to find the maximum or the minimum. And what they then should do is find the max value of this quadratic function. And how do we find a maximum value? I've now drawn it the wrong way around.
Yes.
How do we find the maximum value
It'll
of
be
a
the
quadratic
turning
function?
point.
It will be the turning point. And it'll be...
The x value of the turning point.
No, you find the x value of the turning point, but the y value is the length, the vertical length. So you're looking for
the y value. So even if let's say they got to the point where it was ax squared plus bx plus c, and then they use that magic formula that we teach them, minus b over 2a, they still haven't found the maximum length because they still need to...
They've only found the x value.
Yes.
At which the maximum turning point, the maximum length would be. They then need to substitute x back into this answer that they've gotten to find the y value, which is the length.
Generally, we don't have time to cover questions like this in class. It's really aimed at the top 10% of the grade, isn't it?
Yeah. Or if we have the time, we only do one example.
Yes.
And there are about 2 or 3 learners who understand it, and the rest are left in the dark.
Yes, that is true. Okay, the other 2 links you had were both for Ziavula chapters?
Yes, they were. The textbook chapter was just a general chapter on functions, outlining all the functions. And then the last one was the end of chapter exercises, which
much like the ones that we saw earlier.
Once again gives an overview and asks questions on the whole chapter. And in this case, it also includes trig functions. So when you get to trig functions, that's also included.
Yes. Trig functions, not much new. Well, correct me if I'm wrong. There's not much new introduced in grade 11, is there? There's the horizontal shift.
It is. So it's very similar to functions in that in grade 10, all you're looking at is the effects of A and also Q, so it's a vertical shift.
Okay.
Whereas in trig functions in grade 11, you then get P, which is your horizontal shift.
Okay.
And it works in exactly the same way. Horizontal shift, plus goes up, minus goes down. Sorry, did I say horizontal? I meant vertical. Vertical shift, your plus goes up, your minus goes down. But in horizontal shift, if you have a positive P, you're actually going backwards. You shouldn't go left. And if you have a negative P, you actually are shifting to the right.
And of course, what throws them is they're now working in degrees along the x-axis.
Exactly.
And suddenly it's a whole new concept, and arms are up in the air. And
it gets very difficult.
Yes. Well, not so much difficult, but just
complicated.
They don't want to make that shift.
There's another new thing added to the mix, and it's hard to adjust.
Yes. Okay, now you have once again put together a slide with 3 pressure points.
Yes,
Shall we go over those?
So the 3 pressure points are the effects of P and Q on the graph, and especially P, not only because it's a new concept, but it works in a different way that you expect it to, because learners get very comfortable with how Q works.
Yes.
And they want to keep that same knowledge, and they want to stay in their comfort zone, and so you need to shake them up and make sure. And so that's what I said with number 2. You really need to be aware of the sign changes when working with P. It works in the opposite way of what you expected. So positive P will work in a negative direction, a negative P will go in a positive direction. And then the 3rd pressure point is the application of knowledge, because it's very easy to plot a graph and know the shape, but when you have to find out the lengths of line segments and
maximum distance
and minimum, and the other thing that's introduced in grade 11 is average gradients, so that's a new concept.
Yes.
So when working out an average gradient of a parabola, it's not much different to work that they did in grade 9, but it's now in a new setting, which just learners need to get their head around.
Yeah, I've never understood why they get so flustered about average gradient.
No, me neither.
Yes. Okay, and you have also put together a 5-point teaching summary for us, just based on what we've spoken about now.
Yes, so my teaching strategy for grade 11 functions is it's quite similar to the 5-point teaching summary from grade 10 algebraic functions. And the first point is very similar in that I would just give the parent functions to the learners in each case and get them to plot the points. And this, first of all, is just a refresher of grade 10, because I find that in order to learn new things, many learners forget the old things.
Yes.
So they've forgotten half of what they did in grade 10 by the time they get to grade 11, so they need a bit of a refresher. So I find that gives them a refresher of the shapes of the graphs.
Yeah, you know that most smartphones are there on most app markets. They have function plotters and things like that.
Oh, really?
Yes.
Fantastic.
It might be an easier way or faster way to revise that kind of thing. Yes. Although they don't get the same point-by-point plotting experience, they can at least...
But then you can also plot a point using a graph, using the table function on a calculator, using the table function on a calculator. And then there's also Excel on your computer and other free graphing software such as GeoGebra. The second point is that when the learners know all the the shape of the parent function, then introduce A, and by varying A they'll start to see what that does, positive or negative, making your graph fatter or skinnier in the way of a quadratic function. The third point then is to introduce P and Q and see what P and Q does to each function, and this will be able to this will get the learners to see the effects of P and Q, and that's the vertical and the horizontal shift.
Okay.
And once they've got A, P, and Q, and B in the case of exponential functions, learners will then be able to start getting to do different functions, doing the intersections, doing the lines, and teachers need to just make sure that learners know where to substitute in, because often we get a problem where it says we get given a graph and you get asked the learners to find the equation for the graph, and they need to be reminded to plot to substitute your point into the correct places into your function. Yes. And then my last point is then to move on to some of the much more complicated questions, like finding lengths, reflection around axes, and those sorts of things.
Okay, now I've noticed in our discussions we've spoken mostly about what's covered in point 1, 2, and 3, and hardly touched on point 4 and point 5. And I do find this is a common problem within classrooms, is that we spend so much time focusing on the basics that the more complicated problems, the way they're actually asked the questions,
fall away.
Yes, they do.
Yes, I think there's two reasons for this. The first reason is that it's very difficult to teach application and a holistic understanding of functions unless you know the basics, the procedures, how to plot a function using a table of values. And then the second one is just time pressure. It's very difficult for teachers to get everything done in time, and I think that's one of the cons of our curriculum, is that it's a very dense curriculum, so it's difficult to get through in time.
Yes, it is difficult to get through everything in time. Now I know that you've got a funny slide for us to look at.
Well, this is the slide that I always put up when we learn functions, and it just gives a little bit of comic relief to learners.
Well, the first one being absolute value, second one
x squared. X squared plus y squared. Circles.
So your circle, yes.
Yes. Square root of x, square root of negative x. Those are that's obviously an imaginary function.
I like the hyperbola.
Yes.
Got that going.
And then,
the last
and then the man doesn't know what he's doing. He gets very confused. I've also seen one with sine graphs. There was once a dance move like that.
Yes. Okay. We're going to move on to what kind of mindset resources we have.
Fantastic.
Okay, once again, all of these resources will be posted on my blog, so you will be able to find them quickly and easily. We've got a couple of links there. Obviously, functions is quite an important section, so we've spent a lot of time making good quality resources. We've got live lessons as well as pre-recorded lessons. Remember that the live lessons were recorded with a live audience participation. The audience members were at home, tweeting in as you should be, and on Facebook giving questions to the teachers, and then they would go through various concepts. What's great about these lessons is that they often go through exam type questions. So if you are running out of time and you would like to give learners a bit more to look at, then you can go over there and you can see that they're discussing either the sine or the cosine function there. I'm assuming it's a sine and the effects that different characteristics have on it. And I would assume that that one is the cosine because of where it starts. Okay. Well, we've got just enough time for one last thing. Okay, one last thing is once again taken from the book Teach Like a Champion. And today, the thing is, it almost actually contradicts what we were saying earlier. And they say that right is right. Whatever answer is given in your classroom should be the right answer. And this man, Doug, it's a very American name. Yes, Doug. What do you call a man with a spade on his head?
Doug.
Yes. Okay, so Doug says that if a child gives an answer to a question, it must be absolutely correct for you to acknowledge it as correct. You can't add to it after that. They should be able to add to it. And you can prompt them, but you shouldn't add.
What I also think about this is that when we give the correct answer in mathematics, it has to be precise.
Yes.
And it doesn't matter if we make mistakes in our understanding to get to what is right and what is wrong, but our final answer should always be correct.
Yes, yes. Okay, so strategies he has, and I'm not sure if I agree wholeheartedly with this right is right approach, but let's talk about it with the hashtag VTMaths and see what other people say.
I'd love to continue the discussion after this with any teachers who are on Twitter.
It is. It's a lot of fun, actually. Yeah. So his strategy is that if you give partially correct answer, I would then turn to Dylan and I would say, Dylan, Robin has said this, can you add to it? Rather than saying, well done, Robin, for your 50% answer, let's get the rest from Dylan.
It also sets a very high standard in your class.
It does set a high standard. But if you've got someone who this is the first time they've got anything remotely correct, and then you're not giving them any acknowledgement, I don't know. I don't know if I agree with it or not, but I'd love to hear your thoughts. We would love to hear your thoughts.
And let's continue the discussion after this.
Yes. Thank you for joining us. Thank you to Dylan for behind the scenes. We look forward to seeing you next week, where we'll be talking about grade 12 content. Thank you. Bye.
Bye.